Hi everyone, this is our first video of this weekly digest. In this video, I'm going to walk you through a couple of concepts like data type, numerical summary, and graphical display. So to start with, why do we talk about things like data type? Actually, it's pretty simple because when you are determining which statistical analysis tool you're going to go with, you have to ask yourself two basic questions. First of all, how many variables do we have? And secondly, what types are they? So for instance, if you have two variables, both of them are continuous variable, you might want to consider something called a regression. And on the other hand, if you got one categorical variable and one continuous variable, then you might want to consider something called a ANOVA table. So that is the motivation of us talking about the data type. When talking about the variables, the thing that you should ask yourself is my data taking different categories like Republican, Democrats, or Independent, or something like numbers, like how many children you got. So if it takes some categories, it's called categorical variable. If it takes some numbers, then it's called quantitative variable. It is that simple. In categorical data, you have ordinal data and nominal data. Both of them belong to the umbrella of categorical data. But the difference between them is you can order ordinal data, but you cannot order nominal data. So for instance, if you are talking about the social status of American people, you can talk about four categories. For instance, the wealthy, the upper middle class, the lower middle class, and the ones in the poverty. You can do it like that, and we can order this based on how much money they make, although they are categorical variables. On the other hand, in some of the cases, you cannot order them whatsoever, like races, like gender. So in that case, it is nominal data. On the other branch, which is quantitative data, we can split them into continuous data and discrete data. So the difference is whether you can keep dividing them. Discrete data, they are whole numbers, they are integers. They are like how many children you got in your family. In that case, you cannot have 1.5, you can only have a whole number. In the continuous variable case, what you can actually do is you can keep dividing them. Just think about time, you can dividing them from hours into minutes, into seconds, into milliseconds. You can do this on and on. So in that case, it is a continuous variable. As we have mentioned, we are going to deal with different variables differently. As for quantitative variable, we are going to use histogram to display it. Of course, there are some other visual aid that we can use, for instance, box plot, dot plot, and maybe stem and leaf, something like that. But we will focus on histogram for now. And later on, after we have some knowledge about numerical summary, we will then move on and talk about box plot, because box plot is also a very important tool for you to use, especially to find outliers. So in terms of histogram, there are a couple of things that you have to know. First of all, how to draw a histogram, of course, how to do it in R. And secondly, how to understand a histogram. For instance, you can learn the shape of the distribution by looking at a histogram. Probably it's a unimodal distribution, which means a distribution with one peak, or bimodal distribution, which means a distribution with two peaks, or something like a right skew distribution or left skew distribution. You should be able to recognize the skewness when you see one. Last but not least, you should be able to recognize an outlier when you're looking at a histogram. And as for numerical summary, there are something you got to understand. What is a mean? What is a standard deviation? The former describes the average level of the distribution, and the latter describes the spread of the distribution. And last but not least, you have to understand what is five-number summary. So that five-number summary includes the maximum, minimum, the 25th quantile, 75th quantile, and the median. The textbook provides a very straightforward explanation of how to get a box plot from that five-number summary. First, you can make the box by circling, Q1 and Q3 and make it box. Then you connect Q3 to max, and then connect Q1 to minimum. Then you get the box plot. Where the box plot really shines is to help us to find the outlier. But before we get started, I would like to point out that there is no universal way for us to determine an outlier. People use different ways to find their suspect. With that being said, box plot is really a handy and simple way for us to find out the value that's worth further investigation. So let's see how to use it. In this case, we got a box plot already with Q1, the first quantile, equal to 135, and Q3, the third quantile, equal to 205. Now, the first step is to actually calculate the IQR, the interquantile range, which is given by Q3 minus Q1, the difference between Q1 and Q3, or in other words, the length of the box. So that is 70. And how to determine, now let's see, we have a newcomer, which is 340. Is this guy an outlier? In order to determine if this value is an outlier, we do two things. First of all, we calculate the distance from the right fence, which is Q3, to the suspect, and that distance is 135. Then we compare this 135 with 1.5 IQR. So that 1.5 IQR is 105. So because this distance is greater than 105, which means our observation or our suspect is so far away from the bulk of the data, it's more than 1.5 IQR. So that's why it makes it an outlier. Of course, it can go both ways, by which I mean sometimes we have a very, very small observation, in this case maybe 0. So we want to know if 0 is an outlier or not, and this is how to find out. Still, we calculate the distance from 0 to the fence. But there is slightly a little difference because the fence here is Q1 because we want to go with the smaller side, and that distance from the suspect to the fence is still 135. Obviously, it's greater than 1.5 IQR, and that makes 0 an outlier as well. On the other hand, when we are talking about a categorical variable, we first have to count the frequencies. So this is quite straightforward if you think about it. Like if you want to investigate the political affiliation in a certain area, what you might have in your questionnaire is like a series of answers, like Republican, Democrats, Independents, something like that. So what you want to do is to count for each of the categories how many counts you actually have. And that is called a frequency table. That is also the numerical summary for categorical data. And of course, you can develop a visual display based on that. The most straightforward one is called a bar plot, which is based on the frequencies. And the height of the bar happens to be the frequency that you've observed. Of course, you can feel free to convert them into percentages as well. Okay, now we have figured out how to do numerical summary and graphical display for a single variable. So a natural question is, what if I got more than one variable? What if I want to reflect the relationship between two variables? So to answer the question, we have to learn what variable types you have. For instance, if you got two categorical variables, you might want to plot a stacked bar chart like this. And if you got one categorical variable with a quantitative variable, then you probably want a side-by-side box plot. For instance, if you want to investigate the salary among genders, so you might want a box plot for the male group and a box plot for the female group. Last but not least, if both of your variables, they are quantitative data, you might want to consider a scatter plot and then perform something called regression analysis. All the data analysis tools that we talk about here are relevant and important. And if you're interested, you can go to, I believe it's figure 3.1.1 in your textbook. There is a huge table in which you will find all the statistical analysis tools that you can use, of course, depending on which variables you are talking about, categorical or continuous, and depending on how many variables you have. But for now, it suffices for us to just focus on one variable scenario and focus on how to generate the relevant graphical display and numerical summary for each of the variable type. Okay guys, I guess that's it. So I'll talk to you guys in the next one. Peace.